Okay, here we are on U substitution. This is a technique for integration. It's not always required, but it helps if you have like an inside piece or you just can't see like the pattern and how to do it. So typically we look for our first thing we want to do is choose like a U, right? Which U is usually like the inside piece. So you might have some thing here raised to a third power, and in this case you'd make that thing your U. And the idea is hopefully you see like the derivative of thing somewhere else in your function, and that will help it cancel out. In this first one, you should notice that you don't see like a thing inside anywhere. So like if you don't see an inside, then typically it's going to be the denominator. What I hope you start noticing is that this is x to the third. If I take the derivative of x to the third, I get an x to the squared, x squared, right? So like that's a hint that you want to make your u that bottom piece. You don't want to just make it x to the third though. You want to make it the entire thing, right? And then what we're going to do is we're going to take the derivative of that, and we're going to get 3x squared. The 2 goes away, and we're going to write a little dx right here. And we're going to solve for dx, right? We can divide both sides by 3x squared, and we're going to get du over 3x squared. Right? So now we're going to go and rewrite this integral. I'm going to put that negative here on the outside just to make it easier to look at. There's a 6x squared over there. We let the bottom be u, so the bottom is now u. And our dx, right, this dx is now du over 3x squared. And this is good because this x squared will cancel this x squared, and then the 3 cancels the 6 a little bit to give us like a 2, right? And so now we're left with negative 2, right? Putting that 2 on the outside. Integral of du over u, which hopefully you recognize du over u is like du is the derivative of u, or u prime over u. We're trying to find an antiderivative, so we're asking, well, what did I have to take the derivative of to give me u prime over u? Well, natural log, right? This should be a natural. That should ring a bell in your head like, hey, that's natural log absolute value of u, because it's a indefinite integral. You need plus c, right? There's no limits of integration. And you're not done there. You need to plug in your u. You need to replace it back in here, right? Or sorry, what your x value is back in here, like such, right? And so that would be your answer. You don't need to do any simplification further than that, right? Next one. Again, it's not always obvious what you should choose, but the thing you do choose for u, you want to hope that you see the derivative of that thing somewhere in there, right? So if I take the derivative of tangent, I get secant squared, right? So if I was thinking, hey, I should make u this, well, I don't see a secant squared in here anywhere, right? And then there's also this e floating around. If I take the derivative of secant, I get secant tangent. Look at the secant tangent, that's in there, right? So we're going to make u equal secant 2x. Another good hint on this is like if you have an exponential with a complicated exponent, then that's probably your u. Therefore, du is going to be secant 2x tangent 2x times 2, right? That's chain rule to u prime. And dx is going to be, solve this, right? It's basically just du over secant 2x tangent 2x. Let's put the 2 in the front, right? Instead of at the end, let's put in the front. All right, so let's go rewrite our integral. Let's put the, I'm gonna put the 8 out there. It doesn't matter. 8 secant 2x okay, so secant tangent 2x e to the u, right? We said this piece was u, and then we said that dx was this guy, so we're going to write times du over 2 secant 2x tangent 2x, like such, and hopefully you can see that this is going to cancel that. this 2 will cancel a little bit with this 8 and leave us at 4. And so we're left with 4 on the outside, integral, all that's gone except for e to the u du. And if you integrate e to the u du, you get e to the u plus c. And then you just have to re-substitute what your u was, which your u in this case is secant 2x. And don't forget to write plus c in the final answer. And there you go. Next one. Again, here you can hopefully clearly see a nice inside piece, right? So it's a hint that that's what your u should be, is that inside piece. And if you can just see that, like, taking the derivative of this gives me 10x, which is like this, but this has times 2, then you can really just kind of get to the point where, well, this is going to be, there's an extra 2 in there, so it's going to be 2 this thing over, add 1 to this. But anyway, it's I guess maybe that comes with practice. All right, so we're solving for dx. Dx is this. We rewrite our integral. This is now u to the -3, and dx is du over 10x. And so you can see that this x cancels that x, the 10 cancels with the 20 to make a 2, and so we're left with 2 integral u to the -3 du, which is power rule, right? You're going to add 1, you're going to get u to the -2. You can divide by whatever you get, which is that, and you add c. And so this is going to be 2 over -2 is -1, so negative u to the -2 power, which u is 5x squared plus 4. And since we started with a negative exponent, you don't worry about transitioning there. Number 4. Hopefully maybe you see a nice like inside piece. If this just said secant u tangent u, then wouldn't we be able to integrate that and just get secant, right? Because we know that we should know the integral of secant tangent. So we're going to let u be this. Therefore du is the derivative of that, which is this, 3x squared, and then dx is going to be du over 3x squared. All right, and then we go and rewrite our integral, 6x squared secant u tangent u times dx, which dx is this guy, times du over 3x squared. You can see the x squareds will cancel, the 3 will cancel a little bit with the 6 and give us a 2. So we have 2 integral of secant u tangent u du. Integral of secant tangent is secant. Right, integral, if I take the derivative of secant, I get secant tangent. So put this back in. This was x to the 3rd minus 3 plus c, and we are done. Okay, number 5 is a little bit tricky. It looks kind of nice, right? It doesn't look that bad, but we're trying to figure out, what did I take the derivative of, right? Let me do this over here. What did I take the derivative of to get tangent, right? And like, that's not anything we learned, right? We can take the derivative of tangent, but that's not what it's asking. It's asking, what did I take the derivative of to give me tangent? Which at this point is, we don't know, right? So what we're going to do is we're going to write tangent as sine over cosine. And then maybe it's easier to see that, well, again, if there's no inside piece, then maybe choose the denominator. Let's try the u sub and let u be cosine. Therefore du is negative sine dx. Solve for dx and you get du over negative sine x. Right, so we're going to rewrite an integral for integral of sine x over u, right? We said cosine was u, and we said that dx is this guy, so that's du over negative sine x. And then sine x cancels sine x. We're left with this little negative here, which we're going to end up moving to the front. So this is going to be negative 4 integral du over u, which again, there's that u prime over u again, right? So it's going to be negative 4 natural log absolute value of u plus c, which is therefore absolute value, our u was cosine x, right? So there's that answer, right? And so you're gonna have to be able to recreate that. You might have like a different function up there too, so just be careful, but you can do it. Next one is with a definite integral. You don't have to actually evaluate this, but what this one's trying to do is make sure you understand how to change the limits when doing u sub so that your upper and lower limit are correct, right? So the idea here is they're giving you u, right? Like you hopefully would have been able to figure that out by yourself, and this may not be given every single time. You may have to identify this yourself. We're going to go ahead and do the u sub process, right? So we're going to get du equals 2x dx. Therefore dx is du over 2x. We're going to go ahead and try to rewrite our integral. It's going to be 4x over u cubed. Dx is du over 2x. Let's clean this up, and we're going to get integral 4x and 2x cancel. We're left with a 2 du over u to the third. And again, we're not actually expected to integrate this, but what we are expected to do is, because our variable has changed, right? We have a different variable here. We need different limits, like we need different numbers where these red boxes are. Because up here, these were x values, right? These would eventually get plugged into x. But now we have u's instead of x's. So what we're going to do is we're going to use this relationship here, right? And we're going to find out what these should be, right? So let's start with this one. The 2, x used to be 2, right? So now u is 2 squared plus 2, which is 6, right? So this 6 should go here. And then this 0 here, right? U is x squared plus 2. Therefore, when x is 0, u is 2. So this should be 2. Right? And now I have an integral all in terms of u. That's as far as you're expected to take this one. However, I just want to show you like why we do that, right? So we can go ahead and integrate this, which let's go ahead and rewrite it a little bit simpler first, right? We're going to write this up here. We're going to write it as a negative exponent, so we can use power rule. This is going to become 2 u to the negative 2, right? We're adding 1, divide by what we get, and then we have 2 to 6. This simplifies to negative u, 2 steps here, so the 2's cancel, you get a negative, so negative 1 over u squared, and we're still going from 2 to 6. We'd plug in 6, so we get negative 1 over 6 squared minus negative 1 over 2 squared, which is negative 1/36. Double negatives cancel, give you plus 1/4. You can find a common denominator there, right? This is going to become 9/36, and so you're basically going to get 8 over 36, which is 4 over 18, which is 2 over 9, right? So once you've changed these, you can plug them directly into the u instead of having to put the x thing back in and run from there.